So here we are with the 3x3x5 series. This is the chopped down to the very basic minimum I-cube. So this looks a lot like a 3x3x4. Actually, it seems fully functional over here, yet it's really more of an off-center as it comes all the way down here. And that's because, as you can see with the chopping down process, this is really a 3x3 base puzzle with a cross layer on top, but not a cross layer on the bottom. So it's only part of the story if this were the 3x3 portion here. You've got the top cross, but you don't have the bottom cross. So solving this is actually probably the most straightforward of all the 3x3 series that you're going to have. What?
Cool. Cool.
Cool, okay. Cool, yes. So to solve this, it's really a matter of syncing this layer, because here's the issue. Normally with a 3x3x4, you solve it cuboid style. Cuboid style because the 3x3x4 is really just a 3x3x2 with cross layers on top. That's not what this is. This is a 3x3x3 with a cross layer just on the top but not on the bottom. So because of that, these layers scramble with each other, but this layer is completely isolated. It does not scramble with anything else. So because of that, when you solve it, you're solving this 3x3x1 layer completely independently. You can't do any corner swapping or anything like that because you need a bottom layer to sync it up with, to scramble it against, but you don't. So there's a difference between scrambling and syncing, getting it scrambled or getting it out of sync. So that's going to be the key to solving this. How do you chop it down? It's magic.
That was so cool.
The process of magic.
You should do that for my homework.
I should do that in your work. Yes, I think you're doing that just fine by yourself, chopping that down. To scramble this, you got to be careful because I can take it out like this, but if I scramble it like a 3x3, I'm not taking it out of sync with any of the other layers, which means solving this, once I get it back into 3x3 form, it's just going to be like this. So my suggestion is to solve this, try to get these layers out of sync with each other by doing, say, corner swaps. So I'm going to go over here and I'm just going to do a corner swap. To R, and I have to do it from here, U to R, UI to R, UI, DI, to R, UI, to R, U, to R. And what that did is it swapped these two. Now I'm going to do a middle swap, to R, to U, to R, to U, to R, to U. Now I'm going to take this out of alignment, do another corner swap, to R, U. You can do it any way you want. The whole key is to really make a good scramble with this, is you have to kind of take it out of sync. So we'll do another corner swap, to R, U, to R, UI, to R, UI, DI, you are a goofball, to R, UI, to R, U, to R. So I'm continuing the process of solving this, trying to keep it out of sync here, to R, U, to R, U. This is a corner swap, a middle swap that I'm doing, to R, U. Okay, so why am I doing this? I'm doing this because I want to make sure that we're out of sync with everything else. Now that we've done that, what I'm going to do is just scramble this like a normal 3x3. Turn, turn, turn. What I'm amazed with, and I'll tell you this right now, is kind of a spoiler, I suppose. All of these 3x3x4 are unique in their own special way with the solving. Yes. Turn, turn, turn. Okay, we're going to keep going with this. Abracadabra. Okay, so now normally I'd have like a 3x3x3 to show how to solve it, beginner's method. I don't think I need to do that because really this is just a 3x3 solve. There's no false equivocations. There's no pieces that could be substituted for another. Everything has its place. So I'm going to solve it as such. I'll start off with the Kelvin white center. I'm going to get the cross in first.
That looks scrambled.
It looks scrambled. That's the whole point. Now understand that these layers that come out, this is my one and only cross layer, which is going to be orange. So I'm going to keep that at the side. But so green over here. And now we're going to do another white, white and blue. So turn this here, turn this here. So this is geared up. Turn this up here. So getting the cross, getting the cross. Okay, this is the red and white. So let's find the red area, red area. Oop, there's a red area. and place it up here. So I'm just placing the edges in beginner's method. Okay, so this is an edge in that it's adjacent to a center. It's got a cross area here, which means it must be lined up with this center over here. Turn, and it happens to be the same color. Turn and down. Okay, so far so good. Now, corners. Here's a corner cross with a cross area as well as a green. So this is going to come here. So you can see there's no confusing where it's supposed to be. Put it in here to match up with this cross layer. And now this green, this is another, whoop, actually I'm looking for white. White, green, and red belongs here. So you can do variations of RIDI, RD. Here's another white, red, and green. Bang, zoom, splat. And now this goes here. This is a cross layer to come up with this. So again, nothing other than a 3x3 solve. Simple stuff. So this is actually my first layer. Ignore the exact configuration here. Now I do the middles. Middle is anything that's not orange. Here's a blue with a cross. So this comes here. Now there's only one place for it to go. In all the other cross puzzles, the 3x3x5 variants, there's always at least one piece that can go in multiple areas or multiple orientations. This doesn't. This has to come here where this cross extension ends up over here. U, I, L, I, U, L, U, F, U, I, F, I. So that's it. Now what else? We have a red and blue. So this comes down here. Same algorithm. Turn, 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 turn. And now what do we got? This green comes down to this cross area over here. U, R, U, I, R, I, U, I, F, I, U, F, and that's in there. What else do we have? We've got this red goes down to the green here. Turn, 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 and down. So let's see what we've got. So we have our middle base cube over here. Now it's just this. No parity is involved, no false equivocation. We have the proper orientation of the edges up here. We just have to orient this. Holding it over here, this algorithm will keep this the same. This will flip, and this will flip. So we'll end up with a line here. F, R, U, R, I, U, I, F, I. There's our line. Next, this will flip over here and be rotated right. This will just switch over here, be rotated right, and this will flip and be rotated right. F, R, U, R, I, UI, FI. Okay, let's put the edges in the correct place. This belongs here, this belongs here, and we just so happen to have everything correct. Corners, this is not correct, this is not correct, nor are these, they belong over here. So turn, turn. I'm just doing the algorithm to permute the corners around. Again, if you don't know what I'm doing at this point, it's beginner's method of 3x3 strategy, so no problems. This is wrong. How about this? Well, this one is correct because it's the green edge with a cross area. So I'm going to hold this here, which will permute these guys around. And I'm going to do this until this ends up in this slot. U, R, U, I, L, I, U, R, I, U, I, L. Not yet, so do it again. Turn, 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 and turn. So now everything is where they need to be, including this. Now I do R, I, D, I, R, D until I get all the corners right. R, I, D, I, R, D, R, I, D, I, R, D. And I just keep doing this. Until everything is back. R-I, D-I. So again, this is zero difference to a 3x3 solve. Nothing tricky about this yet. Turn, 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 turn. And we are done here. One more to go. And upon doing this, not only will I have my 3x3 solved, but as with all cuboids, when doing the 3x3 solve, you'll return it to the native shape. In this case, the native 3x3x4 off-center shape. Turn, and now we move this in. Okay, So now where do we go from here? Now we have this side. This is a 3 by 3 by 1, and now normally if we had a 3 by 3 by 5 over here, we would be done with this, and we just sync these two by doing adjacent corner swaps and edge swaps, but you need a layer below here to coordinate it with. Well, in this puzzle we don't. I can't do that just with this layer and keep this intact, because when I move this down, it doesn't have anything to turn against. So what we have to do is we have to understand that this layer only scrambles with itself, and I need to sync it with this layer over here. This didn't scramble with any other layers. It didn't scramble into any other slots. These can have slots all over the puzzle as a 3 by 3. This doesn't. So all I have to do is solve this as a 3 by 3 by 1, but synced up with the solve of this. Knowing that and knowing there's no parity makes this simple. So if I were to solve it the normal way, I'd find the area where my two corners are in, hold that to the left, and do an adjacent corner swap. Well, if I do an adjacent corner swap, I'd have to do 2R, and my U couldn't be here, it'd have to be here, U, which means I'm going to be moving these two as one. When I do that, it's going to swap these the same way it's going to swap this. So if I can just sync up and coordinate the solve of this layer with the solve of this layer, then I'll be good. So what I want to do is make sure that I get all the corners in at the same time that all these corners are in. Well, there's a couple ways of getting my corners based upon the pattern of the corner swapping. Well, first let's talk about the progression of how to get the corners in. So we want to get it to where there's two corners that are in. So here's the usual progression of things, and I'm going to use this to, for the purposes of demonstrating, just scrambling this side over here. In the process of solving the last layer, there is a progression of corners being placed. You may start out with no corners being in. If you see no two corners are in, then do an adjacent corner swap randomly. So I'm just going to do an adjacent corner swap. 2R U, 2R UI, 2R UI DI, 2R UI, 2R U, 2R, and this is moved back. Once you do that, if no corners were in, you're going to have one that is. So this one's in. The next progression that you do is getting all the corners in. And the way to do that is to put this to the left. If you put it to the left and do an adjacent corner swap, you'll have all the corners in. So 2R U, 2R UI, 2R UI DI, 2R UI, 2R U, 2R. It happened to solve all of it, but ignore the centers. You're going to see that all the corners are in. So that's the progression that happens from no corners to one corner to all corners. But let's say you're syncing it with another side and you don't want to put all the corners in yet. If you put it to the left, you'll get all the corners in. But if you put this in the front or in the back, then the next corner swap will simply put another set of corners in. It'll destroy this. You'll still have one set of corner in, it'll just be at a different place. So I'm going to put this over here and do the same thing. 2R U, 2R UI, 2R UI DI, 2R UI, 2R U, 2R UI. What that did is it still kept one set of corners in. It just put it in a different place. Now I can keep doing this over and over and over again, and I'll always be in that second phase where there's just one corner in. I can put it behind me, 2R U, 2R UI, 2R UI DI, 2R UI, 2R U, 2R, move this back, and there this is over here. The other thing that can happen is I can put it to my right. If I put it to my right, what that's going to do is it's going to completely mess these corners up, not get anywhere else in, and I'll be right back to having no corners in. 2R U, 2R UI, 2R UI DI, same algorithm, and you'll find that in this case there's no corners in. So we'll go ahead and get our one corner in. So this is a way where I can keep things with one set of corners in and keep doing that so I can sync it with another side. So if I want to get this in, once again, putting all corners in, to the left we'll put all corners in, to the front or to the back we'll keep just one set of corners in, and then to the right we'll put no corners in. 2R U, 2R UI, 2R, bang, zoom, splat, pow, clunk, clink, clank, and done. Okay, what I want to do is I need to sync these two layers together. In this case, I have one set of corners in, and in the bottom layer or the next layer, all sets of corners in. So I want to make it to where only one set of corners in on both sides. So if I move this over here, my next move, all these corners will be in, and in this case, only one corner will be in, and I'll be out of sync. If I move it over here, no corners will be in, and just a set of one corners will be in, also out of sync. So I'm going to move this over here, do the corner swap, which will make one other set of corners in up here, and only one set of corners in on the next layer. So that's how I use that algorithm and the positioning to try to sync these sides up. I want one set of corners up on here and one set of corners up on this next layer. Then I can sync them together. So when you get this situation, 2R, U, 2R, UI, 2R, UI, DI, 2R, UI, 2R, U, 2R, this moves back. So again, remember to have put it in front of you. And that way, find the other set of corners that are in, just this, and only one set of these corners are in. In this case, it's this. So now it's synced. Because once I put both of these to the left side, doing that algorithm again will put corners in on both of these layers. So now put it to the left. This now isn't in front of me, but it's to the left. If I keep this in front of me, then all of these corners will be in, and once again, only one set of corners will be in, but somewhere else. So put both to the left, do 2R, U, 2R, UI, 2R, UI, DI, 2R, UI, 2R, U, 2R. So we are synced up. Once again, all these corners are in. These will naturally be back, and we'll have all corners in over here. Now we have these to contend with, but here's the issue. Well, not really an issue. This puzzle does not have any parity. Can't have any parity. It's impossible because you don't scramble this in conjunction with anything other than its own side, but it's always synced with this side here. So to put these in, I'm going to be doing adjacent or opposite edge swaps, and although it might cause some placement parity, down here and here, I'll always be able to swap it back. So there's always going to be two swaps. The first swap will put this out and put these out. The second one will put this back and these back. So looking at this, what you also want to do in order to sync it up is don't do any opposite edge swaps if you can't help it. Because once you do that, if you have an opposite edge swap that has to happen here and an adjacent edge swap, you're going to be out of sync because you're going to be affecting this layer exactly the same way as this layer. So my suggestion is find the solid layer and then do a swap to where you put another solid layer right next to this. So if I do an adjacent edge swap over here, this will come out, but I'll have a solid blue and a solid green. That's not going to work because I'm going to have adjacent edges that are going to be out and then opposite edges. And I'm not going to be able to coordinate that. So instead what I'm going to do is I need to do an adjacent edge swap, which will put one right next to here, the green one. If I do it over here, this yellow is going to come here, so I'll have a solid yellow next to a solid green. So this will be good because then I'll have two adjacent edges that need to be placed to coordinate with the adjacent edges here. So again, don't put it to where you have an opposite edge swap that's needed because you're not going to be able to coordinate it with this. So I'm going to move this over here and do an adjacent edge swap to bring this back to here, right next to here, and then put these out. So 2R, U, 2R, U, 2R, 2U, 2R, 2U, 2R, U, 2R, UI, 2R. Okay, we have the expected placement parity here. We have an adjacent swapping that has to happen here. And now you can see these two are in. I just have to put these two in. This is all coordinated to where these two can be placed at the same time as these, and this will be placed back. And this is all synced up over here. 2R, U, 2R, U, 2R, 2U, 2R, 2U, 2R, U, 2R, UI, 2R, and you did it. You solved your 3x3x5 eye puzzle, also called a 3x3x4 off-center puzzle. So that is the 3x3x5 eye cube. Thanks for watching.